in detail, right? Then here we have a RC2, port to C, third pin, and then port to C, fourth pin. Serial clock, right? SCK or SCL. What is the use of this? This serial clock, right? I told that in synchronous serial communication, we have to supply a clock if we want to do a data exchange. Right now, we told, right? From the master to slave, there should be a clock signal. That clock, this pin 18 is used for that. SCL is serial clock. That is supply from microcontroller to slave. Slave or another electronic chip that are peripheral, which is interfaced with this microcontroller. Probably we have a CAN standalone controller. We are going to use SPI to interface. SPI standard to interface that with this microcontroller. In that time, SPI uses synchronous serial communication. In that time, we supply the clock. The clock to CAN controller will be supplied from this microcontroller. In that time, you use this SCL pin 18, right now. And then PSP, not PSP1, I think this is multi-channel MCBSP, multi-channel buffered serial port, something like that. In that time they will use. We'll study them later point of time. And then 21, 22, they are like that only. I believe it is some sort of a configuration or something like that. Then we have a 23, which is SDI. SDI means serial data in. When you interface a CAN controller with this microcontroller, CAN controller is transmitting some packets. That packets will come in to the microcontroller via pin 23, which is SDI. This microcontroller want to command CAN controller to transmit a packet. The command, the packet detail, everything will go from microcontroller to CAN controller using SDO, serial data out, right? So these three pins will work together, SCL, SDI, SDO. For each serial clock, there will be a data output, data input. One bit will go out, one bit will come in. Right. Then we have a RC6, RC7. These two pins are used for asynchronous serial communication. There we don't require a clock. The response is, request will have a flexible response. For that, to do RS-232 communication, when we want to exchange some data from microcontroller to PC or laptop, those will happen only these two pins. We will explain you in detail how to do serial communication from PC to microcontroller. That is a separate program that we have. Then we have BSP4, BSP5, BSP6, BSP7. Those are serial port, multi-channel serial port inputs or outputs. Here also we have port D, fourth pin, fifth pin, sixth pin, seventh pin. Those can be used as a output, digital output pins. Then again VSS, VDD. You have to supply a 5 volt and ground here. Then RB, port B. From RB0 to RB7. This is completely for digital input. In that we have a PGD, PGC, PGM. These were used for in-circuit programming. Right. One of the unique thing that we have in port B is interrupt. The pin 33 can receive external hardware interrupt. Hardware interrupt means this microcontroller is performing a task. Maybe it's doing analog to digital conversion. At that time, if I give a active load to this pin, it will stop the analog to digital conversion. Program counter will be loaded with program memory address 004 because interrupt vector, because this particular microcontroller has only one interrupt vector, which is program address 004. So it will go there. If after going there, if he has some job to do, it will do that. After doing that job, then it will return back to that analog to digital conversion. It will work in that way. Got it now? So this is external hardware interrupt, right? These are the pin details that we have to know about this particular microcontroller. Do you have any doubt in this up to now?
Sir, why there are different like notation VDD, VCC, and VSS like that, VPP?
Okay, I think it is maybe it is V peak to peak digital to for to denote this is a digital high voltage and digital low voltage. These are the notations used by the chip manufacturer, but they used to give some sort of explanation. VDD means 5 volt, VSS means 0 volt, something like that. But your question, if your question is why they used two different VDD, more than one VDD.
Yes, sir.
Right now, more than one VSS. Those were like within a chip, we used to have a lot of circuitry, digital circuitry. We cannot use same voltage input to all the circuitry. Maybe due to avoid impedance or other voltage losses, they provide a additional power supply pin, right? These inputs, whatever the voltage inputs that we give in these pins, no, they will act like a voltage for the circuits, logic digital circuits that we have within this microcontroller.
So we need to give for both this one, right? VDD.
Yeah, here also we have to give 5 volt. Here also we have to give 5
to
volt.
activate the microcontroller.
Yes, to activate the microcontroller. Only then it will wake up and will do the task. If after supplying only one VDD VSS will make the part of this microcontroller circuitry to work. Even if you don't supply this VDD and VSS, the microcontroller will work to some extent, but full operation is possible only when you supply all these inputs. Got it now? If you don't supply these things, some peripheral may not work. You won't get an expected output. Those sort of things. Because circuitries require a voltage input. Based on that only they will work. Now operating voltage is required. So in order to make the microcontroller to work 100%, yes, we have to supply all inputs.
Yes, sir.